be going to all this on base. Today my topic is about the common emitter configuration of transistor and the input and output characteristics of a common emitter configuration of transistor. So these are the things we have to now we have to discuss. So firstly, the configuration of a transistor. The transistor circuits can be designed using the three types of configurations. So these three configurations of transistors are based on the connections of the transistor terminal. The three types of transistor circuits configurations are the common emitter transistors, also called as CE, and the common the second type is the common base transistors, and also called as CB transistor, and what is a common collector transistor, so that is called the CC transistor. So these are the things we have to, so these are the things the so these are the three things that the three configuration of transistor based on the connections of transistor terminal. So these are the three types of transistors. The common emitter configuration of transistor. The configuration in which emitter is connected between the collector and the base is known as the common emitter configuration. So this is the definition of the common emitter configuration of transistor, where the configuration in which the emitter is connected between the collector and the base is known as a common emitter configuration. And now the common emitter configuration, if you see, there is a base P in the input power, the PNB, the emitter P, the collector C, and the output is that. So this is the configuration of the common emitter C. So we have to just look into it. This. And now when the two terminals are needed for the input and the two terminals for output, the transistors have three terminals, so the one terminal has to take it as a common terminal for both input and output. And in the common emitter configuration, the emitter terminal is taken as a common for both input and output. So input is given between the base and emitter terminals, and the output is taken between the collector and emitter terminals. So this is the most common used the configuration, that is the common emitter transistor configuration. And the circuit diagram for the common emitter in NPN and PN transistors. So this is the common emitter configuration of NPN transistor. Input we have IB, and the coming output from IC and IE, the VCC, the common collector. this is the full diagram of this video. The input voltage VB is applied between the base and emitter terminals, and output voltage VC. So the input voltage VB is applied between the base and emitter terminals, and the output voltage VC is applied across the emitter and the collector. The output current IC is taken across the emitter and the collector terminals. The input side is forward biased and the output side is reverse biased. The emitter base region acts like forward bias diode, and so the depletion region is very small. The emitter collector region acts like reverse bias diode, and the depletion region is large. The input current IB it is measurable because the base region is very lightly doped. And now the common emitter configuration of PNP transistor. So this is the circuit. This is the configuration of a PNP transistor. The input and output impedances are the moderate in the common emitter configuration, and thus the current and voltage gain is moderate and the power gain is high. So this the configuration is widely used for the amplifications. And the input characteristics of a common emitter configuration. So these are the input configuration. So as you see in the x-axis there is is microamperes, and and then in the x-axis VE voltage. As it is increasing, VC equal to OV, then the 10 volts and 20 volts. So as you know, the input characteristics of a common input configuration. So this is the input characteristics are a relationship between the input current and the input voltage, keeping the output voltage constant. Here the input current is the base current IB. The input voltage is the base emitter voltage VB. The output voltage is a collector emitter voltage VC. The first output voltage VC is kept at the zero, and the input voltage VB is gradually increased, and the output current IB is noted. Then the again the output voltage VC is increased like 10 volts and 20 volts and kept constant, and by increasing the input voltage VB, the input IB is noted. From the results, it is observed that when the input voltage VB is increased initially, there is no current produced. Further, when it is increased the input current, the IB increased steadily. When the output voltage VC is further increased, the curve is shifts the right side. So this is the output characteristics of a common emitter configuration. So output characteristics relationship between the output current and the output voltage, keeping the input current constant. Here the values of output current ICE and the output voltage VCE is noted, keeping the input current IB constant. The active region, when the output voltage is increased, there is very slightly changes in the output voltage. The curve looks almost flat in the active region. The cutoff region is the region where the input current is zero when both the junctions are followed by a saturation region.